Hey, what's up, guys? Nick White here. I do tech and coding stuff on Twitch and YouTube. Check the description for all my information. I do the premium late code problems on my Patreon. Join the Discord. Message me. I try and get back to everyone. This is an easy problem called flood fill. Pretty cool. 733, a lot of likes. An image is represented by a 2D array of integers, each integer representing the pixel of an image from 0 to 65,535. So we got a 2D array of a bunch of pixels, and it represents an image. Given a coordinate, SRSC representing the starting pixel, row and column, so row and column of the starting pixel of the flood fill, and a pixel value new color, flood fill the image. So we want to flood fill an image from a starting pixel. To perform a flood fill, consider the starting pixel plus any pixels connected forward directionally to the starting pixel of the same color as the starting pixel. Okay, so that's important. Same color as the starting pixel. Plus any pixels connected forward directionally to those pixels also with the same color as the starting pixel, and so on. Replace the color of all aforementioned pixels with the new color. At the end, return the modified image. Okay, great. Instantly, this reminds me of Number of Islands, if you guys saw that. If you didn't, maybe check that out, but it's an easier version of it, actually, so maybe watch this one first, but let's just go through an example. So this is all our inputs. This is a lot. We got a lot of inputs here, right? We're given an image as a 2D array. And I like to look at 2D arrays like this. I think it just looks a lot cleaner when you look at it like kind of like a square. You know, you can visualize a little bit better. Maybe use that as a strategy. And our output looks like this. So let's also get that, right? So how do we get from here to here, right? We have a starting pixel, which is 1, 1, position 1, 1. So 0th row, 1 row, and then first column. 0 column, 1 column. So this is where we're starting at 1, and we're wanting to make the integers represent colors in this. So we want to make the color turn from, the color right now is 1, we want to turn the color to a 2. So we would, what we do is we start at the starting pixel and we change it to a 2, and then we change all of the colors that are equal, remember, same color as the starting pixel, forward directionally to 2s. So we started here. This is our input. We see the starting row, starting column is 1, 1. So if you know indices of 2D arrays, 0 row, 1 row, 0 column, 1 column. Turn that to a 2. Now forward directionally, anything that was a 1, because 1 is the starting color, you can change to a 2. So you could change its up, left, right, and down. These are zeros. These are not the same as the 1 that was there. So you cannot change these to 2s. So this is a 2, but we can change these 1s to 2s because they are the same as the starting pixel color. Boom. Okay, we're good to go there. 2, 2, 2. Now from these, you have to change. You also change all the ones that are connected. Anything you change, you keep going forward directionally from there. So we see more ones to the bottom, top. And then this one to the right, boom, all of them, because it's forward directionally from these. So you got the top down, and then left, right, which is already done, and then this one. You cannot reach this one because there's no way to get there going down and to the right. This is diagonal, so there's no diagonal connection. So that's how it ends up like this, just in case you guys were curious about that. So what you'll notice is we do need to keep track of what the color was at the beginning so that we only change things that are the same color as what we had at the beginning. For a strategy to do this, we're going to be using depth first search, where we do recursive calls. Let's just get into the coding right now. But we're going to modularize and make a separate little method here called fill. So, or you could call, let's just call it fill. That's pretty good. So it's a void method. It does nothing. Fill, and this will fill a current pixel, just 1 pixel. So this will take in the pretty much the same as this, like the same parameters, except it will also take in the previous color. So we can it'll take in the starting color, so we can make sure that we're doing this correctly and we're only changing the starting colors to the new colors. So what this will do is it'll say, okay, at the current row and column, we're just going to make that equal the new color because it's going to be equal to the old color And we do want to assume that. We also, we'll check. We'll be like, okay, if, image SR of SC is not equal to color, that's bad. Or the row is less than 0, so it's index out of bounds. Or the column is less than 0, so column index out of bounds. Or, the index is greater than or equal to image.length. So that's bad too, because that's out of bounds, because the only index it can go up to is image.length minus 1. Column is greater than or equal to image of 0.length, so the column index is out of bounds. So you check all those. And what we'll do is if any of these conditions ring true, we'll just return. We won't do anything. So this method will do nothing if any of these, errors occur. Like, we're not finding, if it's not equal to the starting color, why would we change it to the new color? Like, we're not doing that. Because the starting color is 1 in this. If we found a 0, we don't want to change it. We just want to return. But if the index is in bounds and the color is equal to the starting color, we want to change that thing. And and what we want to do is we want to call this method over and over again, and we want to call it on, passing the parameters in image, the row plus 1. We'll do the row before, so to the left. Actually, that's to the top. Row before is to the top. SC, the same column. Color and new color, and then we'll repeat this 4 times because you're going 4 directions. So what you're doing is the row before, so the top, row after to the bottom, same row, but now to the left and to the right with the columns. So that's it, the row before, row after, column before, column after, and then this recursively just calls doing a depth first search. If you guys don't know what depth first search is, it's going to keep recursively calling until it hits this return, and then the next line, and then the next line. It's look up depth first search. This isn't a depth first search course, but it is a great searching algorithm for problems like this. This is a very common algorithm problem style with 2D arrays. There's a lot of questions that involve like depth first search like this. So now we just want to call fill. So all we want to do here is, well, first of all, if the image of SR if the starting pixel is equal to new color, we'll just return the image because it's already done from what we understand. Why would they should give us a starting pixel with an original color, right? Then we just have to call the fill method with the exact information. The starting image array, the 2D array, the starting column, the starting row, and then the color is just going to be whatever the current color is, the index they gave us. It should not be new color. So this is the original color. So, you look up that, like in this case, we saw that 1. We passed that 1 in. We're like, okay, this is the color, and then we have the new color actual parameter. And then after that, after this gets called, it'll do all of this stuff, recursively calling, do all of those, left, right, top, bottoms over and over again. And then we get our image back. We can return it, smooth sailing from there. Till you get an index out of bounds, guys. Then you're screwed. So, never mind about that. Where is this? What are we doing wrong, guys? If SC is less than 0, SR is less than 0, SR greater than image.length, SC greater than or equal to image of 0.length. Seems, yep, you gotta check this before. Sorry. Check the indexes before, because you can't do a conditional check. You know what I mean? If these are out of bounds, it's going to throw an index out of bounds error. You got to put these at the end of your conditions. That's actually a useful tip too. Always put a conditional check. If you're going to have to check for index out of bounds things, do that before in the conditional check if you're also checking indices, right? Because it'll throw index out of bounds error. So that's pretty much it. Let me know if you guys have any questions on this. Thank you for watching. I appreciate you guys, and I will see you in the next video.